Hello students, welcome to this session. Let us see what is thermochemistry. And in this particular video, I will explain endothermic and exothermic reactions. Okay, so what is thermochemistry? Thermo means heat, all right? So thermochemistry deals with energy changes, that is heat exchange in a chemical reaction. Okay, so before I move on to endothermic and exothermic reaction, let me introduce some vocabulary that will be used in this chapter. Okay, so the first one is system. The system includes the molecule we want to study. So here in this particular example, you can see hydrogen and oxygen. We call that as system. And the surroundings are everything other than the system. So here we can see the cylinder and the piston. These are the surrounding. All right. So the other vocabulary you are going to see is enthalpy. We will be using this term very often. Enthalpy is represented by the letter H. So that is nothing but it's just the flow of energy or the heat exchange at constant pressure when two systems are in contact. And we can see there are different types of enthalpy written here. Enthalpy of reaction, that is nothing but the amount of heat released or absorbed by a chemical reaction. And enthalpy of combustion is nothing but heat absorbed or released by burning a substance. Okay, and then enthalpy of formation is heat absorbed or released when 1 mole of the compound is formed. That is important. 1 mole of the compound is formed from elements in their standard states. Enthalpy of fusion is nothing but heat absorbed to melt 1 mole of solid to liquid. And enthalpy of vaporization, heat absorbed to vaporize or boil 1 mole of liquid to vapor. And as you can see here, all are expressed in delta. So what is that? Delta indicates is nothing but the change. See that delta is nothing but, we read it as delta, and that is nothing but the change. So change in enthalpy. Okay. We will be dealing more with the term enthalpy and enthalpy of reaction and enthalpy of formation. Now let us see how can we explain endothermic and exothermic, and also how are we going to represent endothermic and exothermic in equation, okay, using the word we just learned, that is enthalpy. So enthalpy is represented by the letter H. So let us see that one. So what is endothermic? Endothermic means any reaction that absorbs some heat energy. Okay, so endothermic absorbs. So it is absorbing means we will write on the reactant side. So when the reactants changes to product and when it absorbs heat energy, we call it as endothermic. So in this particular example, carbon combining with the hydrogen to form C2H4, which is ethane. What is happening here is these reactants absorbing 52.3 kilojoules of energy. So that is an endothermic reaction. So in an endothermic reaction, we will write the energy term on the left side. Okay, so this type of equations we call it as thermochemical equations. So this is one way of writing in general. This is in particular we will write like this. And another way of writing the endothermic reaction, thermochemical equation is like this. The reactants gives you the product and we will write the change in enthalpy. And the number will go here with a positive sign. Okay, so that indicates this is an endothermic reaction. So the change in enthalpy will be positive for an endothermic reaction. So now let us see an exothermic reaction. So as we have seen, exothermic exit, right? Exothermic. So thermic heat. Exo exit. Okay. So that means heat energy is exiting or heat is released. Right? So when the heat is released, we call it as exothermic reaction. So since it is released, the energy will be, we write reactants gives products and the heat energy is released. So heat energy term will be on the right side. So another way, in particular example, we can write reactants gives you products plus some energy is released. In this particular example, you can see a number because this is a specific example. So heat term is on the right side of the equation, and when you write it in the third method, the thermochemical equation will give you delta H, which is going to be negative for an exothermic reaction. That's the point you have to remember. Delta H is going to be positive for endo, and delta H is going to be negative for exothermic reaction in a thermochemical equation. How can we represent using energy diagrams? That's also important. So energy is on the y-axis and reaction progress is on the x-axis. So we start with the reactants. This is at a higher energy in the energy diagram here. And these are the products which is at a lower energy here. So when the energy is released, products will have lower energy. So that is nothing but energy released is exothermic. Heat is out. And for the endothermic, it will be opposite. So the reactants will be at a lower energy and the products after absorbing energy, it will be at a higher energy level. Correct? So that is endothermic reaction heat input. This is just exothermic and endothermic in thermochemical equation and how to write and how to plot energy diagrams. All right.